Welcome back. Today we move from theory to practice. In the previous lesson, you learned what units of measurement are and why they matter in physics. Now it is time to use that knowledge. In this lesson, we will practice working with units step by step. I will show you how to read measurements correctly and how to make simple unit conversions. We will use clear examples and solve them together, just like in class. By the end of this lesson, you will feel more confident when working with measurements in physics problems. Let us begin. Before converting units, we must read measurements correctly. Every measurement has two parts: a number and a unit. If one part is missing, the measurement is incomplete. For example, if I say 3 meters, I know exactly what length I am talking about. If I say only 3, the information is unclear. Now let us look more carefully at the units we use in measurements. Before converting anything, it is very important to understand what type of quantity we are dealing with. When you see a unit, the first question you should ask is simple: what does this unit measure? If the unit is meter or centimeter, we are measuring length. If the unit is square meter or square centimeter, we are measuring area. If the unit is cubic meter or cubic centimeter, we are measuring volume. Let us start with length. Length tells us how long something is, or how far apart 2 points are. In physics, the main unit we use for length is the meter. Around the meter, we have larger units and smaller units. These units help us measure objects of different sizes more easily. When we move to larger lengths, we use multiples of the meter. 10 meters make 1 decameter. 100 meters make 1 hectometer. 1,000 meters make 1 kilometer. These units are useful when we measure long distances, like the length of a road or the distance between cities. Now let us move in the opposite direction, toward smaller lengths. These are called sub-multiples of the meter. 1 meter is divided into 10 decimeters. Each decimeter is divided into 10 centimeters. Each centimeter is divided into 10 millimeters. We use these smaller units when we measure objects like a book, a pencil, or the thickness of a sheet of paper. All these units are connected in a clear order. Each step to the right means dividing by 10. Each step to the left means multiplying by 10. This structure helps us convert from one unit to another in a simple and logical way. For now, it is important to understand how these units are organized and what they measure. Let us solve the first conversion shown on the screen. We start with the value 0.06 hectometers, and we want to express it in meters. First, we focus on the unit. The unit hectometer tells us that we are working with length. We also remember an important relation. 1 hectometer is equal to 100 meters. This relation is written clearly on the screen. 1 hectometer equals 100 meters. Now we use this information in our calculation. We keep the numerical value 0.06 and we replace the unit. So 0.06 hectometers becomes 0.06 multiplied by 100 meters. Next, we perform the multiplication. 0.06 times 100 gives 6, so we can write the final result. 0.06 hectometers is equal to 6 meters. Now let us move to the second conversion. We start with 1,200 millimeters, and we want to express this length in meters. Again, we focus first on the unit. The unit millimeter tells us that we are dealing with a very small length. We remember the relation between millimeters and meters. 1 millimeter is equal to 0.001 meters. This relation appears on the screen. 1 millimeter equals 0.001 meters. Now we apply this relation to the given value. We keep the number 1,200 and replace the unit. So 1,200 millimeters becomes 1,200 multiplied by 0.001 meters. We now perform the multiplication step by step. 1,200 times 0.001 gives 1.2. We can now write the final result. 1,200 millimeters is equal to 1.2 meters. These two examples show the same method. First, identify the unit. Then, use the correct relation between units. Finally, perform the calculation and write the result clearly. This method will be used again when we work with area and volume, where the same ideas apply, but the units will be squared or cubed. When we move from length to area and volume, the idea stays the same. Only one thing changes: the factor we use for conversions. For length, each step on the unit scale means multiplying or dividing by 10. This is because length is measured in one dimension. Area is different because it covers a surface. A surface has two dimensions. Because of this, when we convert area units, we multiply or divide by 100 for each step. This comes from 10 multiplied by 10. Volume goes one step further. Volume describes space in 3 dimensions. That is why, for volume conversions, we multiply or divide by 1000 for each step. This comes from 10 multiplied by 10 multiplied by 10, so the method does not change. You still look at the units and move on the scale. The only difference is the number you use: 10 for length, 100 for area, 1000 for volume. If you understand this rule, conversions for area and volume become much easier. A common mistake is forgetting the unit after conversion. Another mistake is changing the number but not understanding why. Always remember, conversions do not change the quantity. They only change how we write it. If you understand this idea, conversions become much easier. Today you practiced reading measurements and making simple conversions. These skills are essential in physics. They help you understand results and avoid mistakes.
Hey, the teacher is waiting for you in the next lesson. We are moving on to something new: determining area and volume. If you want to understand it step by step, make sure you subscribe. You do not want to miss what comes next. Thanks for watching. See you in the next lesson.